I have log base 3 of 5x minus 1 equals log base 3 of x plus 7. Now, if you were a betting person,
Yeah.
what do you think you would do to solve this? You're not dividing by log here.
5x minus 1 is get rid of the log sign. 5x minus 1 equals
What happens? Why does it drop out?
because they're the same. Because
Because
that's
they're the
just like
same.
dividing numeric.
Notice, see how they're the same log base on both sides? If I exponentiated, remember the rule? The exponentiate rule, b to the log base b of x is x. So if I wanted to do the long version here, if I raised both of these as an exponent, then all of a sudden it just drops down. So in essence, that's what we're doing, but you can just go ahead and say 5x minus 1 is x plus 7.
So they just go away.
Yeah. Because what you're doing here is we're using the rules of the base raised to the log of the same base is x.
So if they just go away, why do we have to learn that they go away?
Because you have to know how to set these things up as we get a little more complex. This is just the generic rule here. What do you get for x? 2. Everybody okay with that? Again, if you're not sure of your answer, what would you do to check it?
Plug it in.
Plug it in. Why not?
No. You say, hey, Mr. Murphy, is this answer right?
And then I would say, are you doing electrical work?
Is this answer left?
Remember, it's substitute. What's
That's what we
5?
said.
You said plug it in.
That's
Plug it
substitute.
in.
That's not the same thing. You plug in an outlet. You substituted
You
that.
say plug and chug, plug and chug. How cool is it? Plug and chug. I'm Mr. Murphy. That's plug and chug. Yeah.
Okay. Got me by my own game. All right.
Why is this even?
Yes,
I know.
Wait, do we have to factor that?
I don't know.
Oh no, not okay, not okay.
Do we have the same log base on both sides?
Yes.
So what can I do right away?
Take them away.
Take them away.
Take them to prison.
X plus 2 is x squared. Oh no.
Square root. Oh my goodness.
No. You're not going to
I can't
Set aside equal to 0.
X.
X squared minus x minus 2 is 0. What do you have to do? Negative 2. What times what is negative 2? Add to negative 1.
Negative 2 and 1.
So, what are your zeros?
2 and negative 1.
2 and negative 1, which means you have 2 possible solutions there, correct? What do you have to do to see if both solutions work, only one of the solutions work, or neither of the solutions work?
Plug and chug, Murph. Plug and chug.
Oh, I get it, like chug water.
Log base 2 of 4. Is that going to equal the log base 2 of 4? If I substitute in 2, am I going to get 4 on both sides?
Yeah.
Okay. Is log base 2 of, well, what's negative 2 and 1?
Negative 1.
Wow. Isn't it? Negative 2 and 1
What's
is negative
negative 1 squared?
1.
Oh, that's 1.
Do they both equal the same thing?
Yeah.
Okay. There will be a time that they may not both work. You have to double check some solutions every once in a while. You might have to do that. I heard someone say wait. Okay? Again. Guys, what did you do yesterday when we had this problem?
You had to.
You had
Oh, you had
equals 7.
You had to take the
What'd I
log
do?
of 2 on
Log, yeah.
log 2 on each side.
I had log 2 of both sides. So I would get x was equal to log base 2 of 7, correct?
Yeah.
That's what we did yesterday. What do you think I have to do today?
Same.
Okay, what do I have? What is giving me the log base?
5, 2. On 5.
Good. So I get 3x plus 1 is log base. Oh, excuse me, I'm going backwards here.
Wait, what?
I was thinking about a different problem. Excuse me. I'm sorry. I was thinking of a different problem. I did this earlier too. What is this rule again? What does that equal? Okay. In order for this to work, we had to have these two bases be the same, correct?
Yep.
I have to exponentiate. I was ahead of myself here. What is the base of the log on the left?
1. 5.
Oh.
So what do I have to put as the exponent or the base for the other one?
5.
Okay.
So it's 25.
Correct.
So 3x plus 1 equals 25.
Very good.
No.
And I'm sorry, for some odd reason I was thinking I was doing a different problem. I got ahead of myself. I think that's the next example.
Richie got excited.
So now, what I've done here is we've exponentiated each side. That allows us to get rid of a logarithm. By turning the logarithm into the exponent, as long as the logarithm and the exponent now have the same base, you're going to be just fine. Does everybody agree here it's going to be 8?
Yeah.
We're okay on that one? Okay.
24 divided by 2.
So you can always go back and double check in your answers, and that's fine. The other example I had for this one, I think.
Yeah, that was hard because it's 2 in there. 1 over 2.
Subtract 15 times base 2.
Subtract 15 squared.
No, don't subtract.
And you put 2.
15 plus 2 times the log base 2 of x is 31. Again, this is setting us up to look like a multi-step equation. And I still want to try and get the value of x. Which means I got to do a whole bunch of other junk before I can move stuff around.
You want to condense it or rewrite it or no?
Sometimes you can, but you don't have to. Now, I can't move the 15 to become part of that log, correct?
No, you can't. So you want to minus it.
Right. I got to move that around first. Everybody understand what he's asking here?
Yeah.
He's asking if I'm going to want to try and condense any of this. There will be times if you do condense and you follow those rules, you will get the same result. Some people see it that way, and sometimes they think it's cleaner. It's fine. Personally, I work backwards just like I would any other equation. Does everybody agree I would have to move 15 first?
Yes.
Okay. So I have 2 of log base 2 of x is 16.
Base 2.
Now do I what? Divide by 2. Now, Hunter, did you do this doing the condensed version?
Did I?
Yeah.
I did not. I'm with you.
Okay. I'll show you the other way with the condensed thing. You'll see it's the same answer.
32.
Now, in order for us to get rid of that log base 2, what is the
2.
exponent I have to put below it? 2. So I have to exponentiate, I think it's the right word, both sides. So now what is 2 to the 8th power?
256. Actually, those 256.
Okay. And that's where you get that. Now, if you solve that in your head earlier, the other one, oops,
Log 2x.
if you wrote this out using the condensed formula, this is the same thing as saying log base 2 of x squared is 16. Do you agree? Yes? Okay. I would have to exponentiate both sides. Do you agree?
Yes.
Same thing. Raise it to a 2. 2 to the 16th power is
then
6,
you take
5,
square root.
5, something, something. And then if you square root it, you're still going to get,
286.
you're going to get the same result.
That's fair game.
So it does work if you want to work with some of the condensed rules.
Harder.
It does work. It's not so much that it's more difficult or anything. It's just sometimes people see it that way. It's the same amount of steps. It's just, if you see it one way or the other, it's going to work out just fine. Okay?
What do you want?
Me?
Me.
I should know better.
Is it June yet? Oh dear.
Look outside, Joel.
I heard that. Last
From
time I
my
heard
point of
that, I
view,
thought
it's
my
sunny.
dinosaur
It's nice
was
outside.
right.
Yes.
I did not hear what you said.
I wouldn't bother with it,
He
just
said last time I
basically.
heard that
Okay.
joke, I fell off my dinosaur.
What?
Old
I can't
joke.
believe that.
I mean, it's an old joke. So last time I heard it, it was last
Blinders. Just pay attention.
You should break her up.
Yeah, summary, write her up. Okay. Now, I've got log of 5x plus log of x minus 2, or x minus 1, is 2. Whenever you have a problem that has multiple logarithms or multiple natural logs, you're going to want to use your condense rules prior to doing anything. So in this problem here, there's an addition sign. What does that mean for the parts of the log? Multiply, good. So what I want to do right away is I'm going to rewrite this in condensed form. The time that I'm going to do this, remember, is if I have more than one log on a side, I'm always going to condense it to a singular log. We get the log of 5x times x minus 1.
Yeah.
From there, again, I have to exponentiate both sides. What's the base of the log? 10. Good. So basically, I'm doing this. What's 10 squared?
100. They're all
Okay.
hundreds.
So now I have 5x squared minus 5x is 100. Move it over.
This is really hard.
And what's your first rule of factoring?
5 times. Oh,
GCF.
GCF. What do you divide everything by?
5.
Good. What times what's negative 20? You add together to get negative 1.
What was it?
-5.
Negative 5 and 4. That gives me zeros of
5 and negative 4.
Good. You get 5 and negative 4 for your zeros to check.
How did I get x is equal to the square root of 5 over 26?
Late.
Okay. Your explanation is here. You can't do this because it's a different base. Choose right away. That one's base 10. When we see these things, we can add some right away.
What?
Yeah, that's why I'm rewrote it as the log.
Oh, so yeah, that's 5.
Yes. It's just cleaner that. So again, in this case here, you got to double check both solutions. If you double check 5, it works. But if you double check negative 4, it doesn't work.
No.
No, so what do you do to the negative 4?
Cut it out. Cut it out.
Again, one thing I will remind you guys of, if it's only a single answer, it's very quick to check one answer. If it's 2 possible solutions, always just take a second to double check your solutions, guys. It only takes a second, okay?
Worth it.
All right. Does anything change when we have natural log?
No, it is the same. How do you undo me again? Sorry.
Natural log.
See, literally, it's natural log.
For example,
So if you throw a natural log on each side, it just straight stays with the one side. They just like cancel out and then the other
because it's
side.
not easy.
Something is
Okay.
daily over the course of time.
So I have 1 minus 2 times the natural log of x is negative 4. What's the first thing I'm going to move? The 1, all right. So now I get negative 2. Natural log of x is negative 5. What do I do with the negative 2? Divide it out. So I have natural log of x is 5 halves. How do you undo natural log? You just e it. You exponentiate it with e. Remember, natural log is the log base e. So if I exponentiate it, this value just comes here.
E to the 5 seconds.
E to the 5 halves. And that's your answer.
That's a horrible
Yep.
decimal.
It is a horrible decimal, but that's all it is.
Snake for lunch.
Ooh.
Again, when you're dealing with natural log, just remember it's nothing more than log base E. Yeah.
So you put both natural log x and 5 halves to the e, right?
Yep. Just
Then
like I would
Why doesn't that one cancel? Why doesn't that e cancel in the answer?
in here.
Yeah, why doesn't that cancel?
It doesn't because it's canceling on this side here.
Okay.
Because natural log is log base E, so this is why it drops to the regular exponent.
Okay.
Just
the
if
other
I had-
e has to stay.
Correct. Because if this was, if it was log base 2 of x equals 5 halves, I'd have to go like this to get my x value.
Yeah.
Just so happens that E is a numerical number, it's just some crummy looking number. Does that make sense?
Yeah.
Good question.
We good to get our problem?
All right, we'll use some stuff.
I already have
You would have been born in the 70s or president.
I didn't bring my music.
Fought. Might not be War 18.
I work all day.
One last reminder. These last 3 problems deal with exponential growth or exponential decay. They may be dealing with compound continuously. They may be compounding quarterly, monthly, or whatever. But you will be using one of those formulas from sections 8.1, 8.2, or 8.3. So you might have to go back and revisit that so you remember how it sets up. Yes, sir? Yeah, 43 to 57 all. The reason I'm telling you not to worry about numbers 51 and 52 is because in order to solve them, you'd have to use the quadratic formula with E. Yes, ma'am. Why don't you use your phone?
Yeah, scared of phones.
The irresponsibility of this.
Because what?
Charts.
Because you didn't bookmark it yet?
Well, I don't know how my book works.
You put them on whatever page you're reading.
Wait,
when you
no.
close the book.
No, I bookmarked. I just don't know how it works.